So we're going to be looking at the midterm. So here we have a piecewise function. And for this piecewise function, we have to answer the following 4 questions. So first they want f evaluated at 2. And so our x value is 2. So we only use this formula if x is a number less than or equal to 0, but x is 2, so we're not in this case. The number 2, if x is 2, it's between 0 and 3, so this is the formula that we use. And so then f evaluated at 2, I just replace the x with the 2, and it's going to be equal to 1. Next we need to find f of 0. Well, if x is equal to 0, then this is the case that we're in. Here x is less than or equal to 0. If that's the case, that's the formula we use. So if x is equal to 0, the formula that we use is this. And that's going to be 0 plus 3, which is just 3. And so the answer is B. Now we want to find f evaluated at -2. So x is equal to -2. So once again, this is the case we're in. I use this formula for f if x is a number less than or equal to 0, and -2 is less than or equal to 0. So this is my formula. And so f evaluated at -2, I'm going to replace x with a -2 in parentheses. -2 all squared is positive 4. And so my answer is 7. And finally, we need to find f evaluated at 3. So x is equal to 3. I'm not in this case. I only use that formula if x is a number less than or equal to 0. In this case, x is 3. I'm not in this case. I only use this formula if x is a number between 0 and 3. But my x value is equal to 3. And for the same reason, I'm not in this case. I only use this case if x is strictly greater than 3. I need to find x is equal to 3, and it doesn't happen here anywhere. And so what we have in number 4 is undefined. Graph the function. Okay. So the line, the function f of x equals 7 is the horizontal line going through 7 on the y-axis. The function f of x equals -7 is the horizontal line going through -7. Let me get a different color. So that's what each of those 2 functions look like. But remember, this is a piecewise function. So we only want this function when x is strictly greater than 5. So only when my x values are bigger than 5. So only the stuff past 5. So here 2, 4, there's 5. So that could be one of it. That's going to be the only possibility. I want this function, this graph, when x is greater than 5. And I want this graph when x is less than 5. So if this is where 5 is, I want this graph when x is less than or equal to 5. So I do include the point and then everything. And so this satisfies both conditions. And so my answer is going to be B. So you have to pay attention to the symbols. X strictly greater than 5. Oh, sorry. Is going to be that portion. And then I want it to be -7 if x is less than or equal to 5. So I want that point because it's less than or equal. And so that's what I'm going to get from those. Okay. Now, from what we should know about functions, this is a square function, x squared minus 4, and so it's going to be a parabola. And in fact, x squared minus 4, from what we learned in Math 100, is the graph of x squared shifted 4 units down. So that's the total graph of x squared minus 4, but I only want it when x is greater than or equal to 0. So I do include this point because x is 0, and so I only want the part in red, the piece in red. That's going to be a line, and I only want that line when x is strictly less than 0. And the line 2x plus 6 do a zoom 6. There's the line 2x plus 6. I only want that line when x is less than 0. So let me put that down here. I only want this line when x is less than 0. So I do not include this point and just have the part of the line when the x values are less than 0. So putting these two together on the same graph is going to give me that one. All right, and finally we want to graph this function. Okay, that is going to be a parabola. And we only want the parabola when x is less than or equal to -1. So far so good for this one, because that's a curve there, that's not a straight line. So all of them have that correct. Okay. I only want f of x equals 2 when x is between -1 and 1. So f of x equals 2 is the horizontal line going through 2, but I only want that when we're between -1 and 1. And because of the symbols here, we do not include the endpoints. So I'm looking for a graph that has that at 2, and we have it here. I don't have it there because the endpoints are included. I don't have it at all there. Not right here. But let's have a look and see what 2x squared looks like. Do they meet like here or do they not? So far I know I've got that portion, but is that going to be filled in? What's 2x squared look like? Let me clear that and let's do 2x squared and do a zoom 6. Okay, and let's see what I get at -1. Second graph. And see, these are telling me what points I have. And I've got the point -1, 2 is on the graph. So this is the part of the graph that we want. There's the total graph, and this point here is negative 1 comma 2. So when I put these together, when I put them on top of each other, this point fills in the gap there. And so I am going to have that negative 1 comma 2. So there's negative 1, 2, 3, 4, negative 5. And these go up by 2s, 2, 4, 6, 8, 10, 12, 14, 16. So that point there is negative 1 comma 2. And that is what we want. When I put these on top of each other, this point fills in that gap. That's what we want. Okay. So this is stuff that we learned from Math 100. That we still have to, f minus g of x is f of x minus g of x, which is the formula for f of x. Then we got to be very careful here. It's minus the entire formula for g of x. So minus x squared minus 3x minus negative 4, which is plus 4. Now, I like to write this with the highest powers of x first. So I have an x squared here, but nowhere else. So negative x squared. Then I have a 3x minus 3x. They cancel each other out. Then I have a negative 2 plus 4, which gives me positive 2. Now, what is f evaluated at x plus 1 if this is my rule for f? Well, I write this without the x. And wherever there's an x, I put blank parentheses in there because I want it evaluated at x plus 1. So x plus 1 goes inside the parentheses. But as we can see here, the answer, even though this is a correct answer, it's not in the form of our selections. So I have to write this without parentheses. X plus 1 all squared is not x squared plus 1 squared. X plus 1 all squared is x plus 1 times itself. Here, the negative 2 has to be distributed through the parentheses. So I'm going to have a minus 2x. Then minus 2 times positive 1, which will give me minus 2, and then minus 1. Here I have to FOIL that, which we learned how to do in Math 100. So I'm going to have x squared times x, plus x, plus another x, which will give me plus 2x, and then plus 1. FOILing was done in Math 100. So I'm copying this, and then that's going to give me minus 3. Now, look in here. I've got a plus 2x and a minus 2x. They cancel. So I'll have x squared plus 1 minus 3. So that's going to give me x squared minus 2. Now, notice the symbols here. This is unquestionably f times g. And that's f of x times g of x. So it's going to be the formula for f times the formula for g. And there's no other way to simplify this. You cannot multiply the 7x squared through the square root. If that were parentheses, you could, but it's not. It's a square root. This cannot go inside. That's as simplified as it gets. Now, what is f composed with g? The symbol here is composition. So composition is the first one, f, evaluated at the second one. So f evaluated at, well, what's the formula for g of x? It's the square root of 5x plus 3. So this is what I want, f evaluated at the square root of 5x plus 3. So what we have to do is rewrite the formula for f without the x and just have blank parentheses wherever there was an x. And inside we want to evaluate this at square root of 5x plus 3. So this is a correct answer, but it's not in any of our selections in the form. So, well, what do we have here? 5x plus 3, it's the square root of, but the square root is the same to the 1/2 power. And if I square something to the 1/2 power, 1/2 times 2 is 1. Or another way to think of this is squaring a square root, they undo each other, and you just get what's inside here. Now, since it's parentheses, I can pass the 7 through. 7 times 5x is 35x, and distributing the 7 to the 3 gives me plus 21. All right, so what is f composed with g of x here? Well, it's f evaluated at g of x, which is going to be f evaluated at, well, the formula for g of x is x minus 5. Now, what's the formula for f? I write it without the x and just have a blank parenthesis where the x was, because now I want to evaluate it at x minus 5. This is a correct answer, but none of the selections look like that, so I have to write it correctly without parentheses. X minus 5 in parentheses, all squared, is not x squared minus 5 squared. It is, so this is from Math 100, it is x minus 5 times x minus 5, then we have to FOIL. So that becomes x squared minus 5x, and then I have minus 5x, and minus 5 times minus 5 is plus 25, and then I can put those together. It's a minus, sorry. And so the one I'm looking for is C. For these next ones, we have a table. So here, f composed with g evaluated at -2 is f evaluated at g evaluated at -2. What is g evaluated at -2? I get g, and I find -2, and so g evaluated at -2 is 0. So I'm replacing what's underlined with 0. Now to get the answer, what is f evaluated at 0? I get f, and my x value is 0, and these match up at -1. F evaluated at 0 is equal to -1, and so that's my answer. What is g composed with f evaluated at -1? It's the first one evaluated at the second one. I have to find out what that is from the table. So I want f, and my x value is -1, and these meet at 2. And so what's underlined here is equal to 2. So this becomes g evaluated at 2. Now I need to find g evaluated at 2. I go to g, I find 2, and they come together at 0. So g evaluated at 2 is equal to 0, and that's my answer. Now I need f composed with itself at 1. So that's the first evaluated at the second evaluated at 1, and I have to find out what f evaluated at 1 is. So f and 1, and those meet up at -2. So I replace what's underlined with -2. Now I need to find f evaluated at -2. So f and -2, and they meet at -1. And so my answer is -1. And finally, I need g composed with itself at 1. So the first evaluated at the second. So I need to find out what that is. So g evaluated at 1 gives me 2. And so what's underlined becomes 2. And the last thing I need to do is find g evaluated at 2. So g and x is 2, and those meet together at 0. And so my answer is 0. Consider the one-to-one function 5x minus 10 all over 3. Determine the formula for f inverse. Well, what we don't do is flip that, because it was a process that had 4 steps. And if all you had to do was flip it, we wouldn't have learned a process that had 4 steps. So it's not going to be that one. So the process was, the first step was to replace the f with a y. And the next thing we had to do was swap the x's and the y's. And the last thing we had to do, and this is what takes the longest, is to solve this for y. Once we solve it for y, we've pretty well got it, which means you want to get y by itself, preferably on the left-hand side. Well, what I'm going to do first is multiply both sides by 3. So 3 times x, and then 3 times this. Well, this is a fraction, so the 3's are going to cancel. Now, in solving for y, you want to get y by itself. So what I'm going to do next is I'm going to add 10 to both sides. So over here I have 3x plus 10. Those cancel and I have 5y. To get y by itself now, I'm going to divide both sides by 5. So the 5's cancel and I'm left with that. Now, I said get y by itself, preferably on the left-hand side. So now I'm just going to swap sides because I have equality here, so I can just swap sides. So 3 times 2 is equal to 6. If I want to swap sides, that's still true, isn't it? So that's all I've done here is I've swapped the sides. Now, once you've solved for y, you have your answer. So that is my inverse function. Okay, now let's look at the selections. I need 3x plus 10 over 5, so it's not that, it's not that. Now let's just wait a minute here. This is one function, this is one fraction, and here we have a fraction and something else. So it's going to have to be one of these. And so what they've done is they've just split this into 2 fractions. Now, up until now, if you saw that, you would put those together in one fraction because they have the same denominator. We've gone from separate to one. Well, again, if there's an equal sign there, there's nothing stopping us from going the other way, from taking one fraction like this and splitting it up into 2. So that's what I'm going to do here. Because this wasn't in my answers, so this is the same thing as 3x over 5 plus 10 over 5, but 10 over 5 is just the number 2. So 3x over 5 plus 2. There we go. Okay. All right, so the solid represents f, and the dashed represents the function g. Okay. So what is f evaluated at 4? Okay. The number inside the parentheses is the x value, the x coordinate. And on the graph of f, I can see here is the point 4, 2. Now, what does a function do to a point on the graph? The function maps the x coordinate into the y coordinate. So f evaluated at 4 is equal to 2. The answer is 2. The answer is not the point 4, 2. 4, 2 is what you have to locate, and then you get the answer because f maps the x coordinate into the y coordinate. So the answer is 2. not the point 4, 2. Now, what is f composed with g evaluated at -1? Okay, well, this is the same thing as the first, evaluated at the second. Okay. Now, from the map, I need to find g evaluated at -1. So the number inside is the x-coordinate. So if the x-coordinate is -1, this point is on g, -1, -2. And so g, what does a function do to a point on its graph? The function maps the x-coordinate into the y-coordinate. So g evaluated at -1 is equal to -2. So I'm going to replace what's inside here with -2. G evaluated at 1 is equal to -2. And so what I have to find now is f evaluated at -2. So the x-coordinate is -2, and I have to see where that point is on f. X-coordinate of -2, and this is the point that's on the graph of f. And so f maps the x-coordinate into the y-coordinate. So f evaluated at -2 is equal to 0. And so my answer here is 0. What is g composed with itself at -5? Well, it's going to be g evaluated at g of -5, and I need to find out what that is. So the x-coordinate is -5. There's -5 on the x-axis, and I need to find the point whose x-coordinate is -5 that's on the graph of g. G is the dotted one, the dashed one. And so here I've got -5, 4. Now what does g do? It maps the x-coordinate into the y-coordinate. So g evaluated at -5 is equal to 4. So I'm going to replace what's underlined with 4. Now I have to find this. So I need to find the point whose x-coordinate is 4, and the point is on g. So here's 4, and here is what looks like to be the point on g. And that matches up there with -1 on the y-axis. So this is the point 4, -1. So what does g do? It maps the x-coordinate into the y-coordinate. So g evaluated at 4 is equal to -1. I come down here and I have -1. All right, which represents a one-to-one function? Well, to be a function, you can't have any repetition in the first coordinate. So this is a function, so it's in the running. This is a function. This is not a function because I have repetition here in the first coordinate. So this isn't even a function. So both of these are functions, but only one is one-to-one. What does one-to-one mean? No repetition in the second coordinate. And we can see here there's no repetition in the second coordinate. So that will be a one-to-one function. This was a function, but we have repetition in the second coordinate, so it's not a one-to-one function. Okay, let f be this function, so it's a collection of these 4 points. Find f evaluated at 1. Well, the number inside is the x-coordinate, and here we go, x-coordinate of 1. Since it's a function, there's only going to be one point with an x-coordinate of 1, and f maps the x-coordinate into the y-coordinate. So f evaluated at 1 is going to be equal to 2. Now, it wants f of x to be the same function, but they're asking us for f inverse of 1. Well, this is the function f, and to get this, I need to know what f inverse is. Now, what did we say? If you know a function is 1 to 1 and you know a point on f, then you know for sure a point on f inverse. You swap the coordinates. So I'll have 4 points on f inverse, and they will be, well, swapping these coordinates gives me 0, negative 1. Swapping these coordinates gives me 1, 0. Swapping these coordinates gives me 2, 1. And swapping these coordinates gives me negative 1, 2. Now we need to find f inverse evaluated at 1. So for the function f inverse, I need to find an x coordinate of 1 for f inverse, not for f. And here we go. And so what does a function do? It maps the x coordinate into the y coordinate. The name of this function is f inverse. So f inverse evaluated at 1 is going to be equal to 0. Once again, this is the same question that we had before, except we have a graph now. So they don't want f of negative 1, they want f inverse evaluated at negative 1. Let's get some points on f that are easy to identify. I'll do this one. That one's 1, 0. That one's 4, 1. And that one's going to be 5, 3. I can see that this is a one-to-one function because it passes the horizontal line test. So its inverse exists. And I've got 1, 2, 3, 4, 5 points on f. I can get 5 points for free. I know I have to be on the inverse. I swap coordinates. Now let me plot these. Negative 3, negative 4. Oh, sorry. That one there. I have white out. I do. Hooray. All right, so it's like it never happened. So negative 3, negative 4. Negative 1, negative 2. 0, 1. Uh, 1, 4. And 3, 5, which would be about there. So I'm doing a bit more than just answering the question. So in red is the inverse. And as you can see, it would be symmetric with respect to the line x equals y. And I can see, where does f inverse take negative 1? Well, there's the point that I want. I can see that f inverse, because that's the name of the function, takes negative 1 to negative 2. Okay, which of the graphs depicts a one-to-one function? Well, that fails the horizontal line, so that's not one-to-one. That fails the horizontal line test, so that's not one-to-one. This fails the horizontal line test. This passes the horizontal line test. Any horizontal line I care to draw only hits it at most once. So this one is a one-to-one function. Okay, find the domain. Fractions are not allowed to have 0 in the bottom. So p is not allowed to be negative 3 here. If p is negative 3, that makes the bottom of this fraction 0, which is not allowed. So any p value, as long as it's not negative 3. This is a fraction. You cannot have 0 in the bottom. So a is not allowed to be -9. Otherwise, that's going to make it 0. This is a fraction. You cannot have 0 in the bottom. So here, x is not allowed to be -1. If x is -1, that's 0. And you have 0 times that, so the whole thing's 0. But also, we can't have that being 0. So that's not allowed to be 0. But I have to solve this for x. What is x not allowed to be? They're saying this is, so here's one condition. We can't have -1. But this says 4x minus 3 is not allowed to be 0. What is x not allowed to be? We'll add 3 to both sides. And so we get 4x is not allowed to be 3. And then divide 4 from both sides, and we get x is not allowed to be 3/4. So I have these two conditions together. And there we go. So my answer is A. Find the domain of the expression. Well, it's a fraction. You can't have 0 on the bottom. So let's see if we can factor that. Math 100, we should know how to factor this. Are there two numbers that multiply together to give me -18, but at the same time add up together to give me -3? Well, -9 times +2 is equal to -18, but that won't add up to -3. -6 and +3. -6 times 3 is -18, and -6 plus 3 is -3. So I can factor it like this. And once it's factored, and it's a fraction, I don't care what the top is. For the domain, I just have to see I can't have 0 on the bottom. So x is not allowed to be 6 here, or that'll make the whole thing 0. And x is not allowed to be -3 here, else that'll make the whole thing 0. So be very careful. It's not A. It's what I've written here in red. Okay. Find the product. Okay, now we have to remember how to factor so we can do some cancellation, because it's going to be in canceled form. So, two numbers that multiply together to give me 14 and add up to give me 9, well, 7 and 2. So k plus 7 times k plus 2. And here, two numbers that multiply together to give me 16 but add up to give me 10, 8 and 2. So k plus 8 times k plus 2. Now, if I'm multiplying fractions, they can be one fraction and just multiply everything on the top. Now here, what do these two have in common? They have a k in common. So I factored it out. And what two numbers multiply together to give me 28 but add up together to give me 11? Well, 7 and 4. So k plus 7 times k plus 4. Now I cancel. So I have a k plus 2 here, because I've got product in the top. Everything's a product. Everything's a product. So the k plus 7s cancel, and the k plus 8s cancel. So what am I left with after all of this? I have a k in the top, and I have a k plus 4 in the bottom. Now, you cannot cancel the k here, because that is k plus 4. You cannot cancel those out and then say, I don't know, 1/4 or 0/4. You know, you cannot cancel the k's. If I have that, then since that's a product, I can cancel the k's, but we cannot cancel the k's here. So it's k over k plus 4. Find the product. I'll do the same thing again. 3 times 3 is 9, and 3 plus 3 is 6. So that'll be k plus 3 times k plus 3. 7 times 3 is 21, and 7 plus 3 is 10. 7 and 3. And here they have a k in common, so I can factor it out. 27, 9 times 3. Okay, so positive 9 and, no, negative 9 and positive 3. Negative 9 times 3 is negative 27, and negative 9 plus 3 is negative 6. Now I have product, that's product of 4 things in the top, product of 4 things in the denominator, so the k plus 3's cancel, and the k plus 7's cancel, and I'm left with k over k minus 9. 32, find the quotient. Well, that's going to be the same thing as the first one, unchanged, times the flip of the second one. So if it's a quotient, we have to do that rule first. Now, 7 times 4 is 28, so this is going to be that. 6 times 8 is 48, but 6 plus 8 is 14, so that will not work. Oh, that's a 42. My bad. Okay, 6 times 7 is 42, and 6 plus 7 is 13. Okay. 24. 6 times 4 is 24, and 6 plus 4 is 10. And these have a z in common, so I'm going to factor it out. So those cancel. I have a z plus 6 canceling, and the z plus 7's cancel, and I'm left with z plus 4 all over z. I cannot cancel the z's because it's z plus 4. If it was z times 4, I could, but we cannot cancel the z's here. Okay, another quotient. So the first is going to be unchanged. But it's going to be times the flip of the second one. So I'm going to have 6 and 3 there, z plus 6 and z plus 3, and not 6 and 4, 8 and 3 for this one, for that to work. And here, 6 and 8, so I'm going to need positive 8 and negative 6. And here they have a z in common. So a z plus 6 and a z plus 6, z plus 3 and z plus 3, z plus 8 and z plus 8. I'm left with z minus 6 over z. The z's do not cancel. Z minus 6 over z's. Okay, perform the indicated operations. If I'm adding, they have the same denominator, so they go into one function, into one numerator. This is correct, but it's not simplified. 10 is the same thing as 2 times 5. 6 is the same thing as 2 times 3, and then we have the x, and now the 2's cancel. And so I'm left with 5 over 3x. Now, I can't put these in one fraction immediately because they don't have the same denominator. Now, I don't want to change the value of that, so I'm going to multiply it by 1, and 1 is going to be of the form x over x. So this will give me the fraction 3x over 10x squared. Okay. So, I think they're both factors of 70. 14 times 5 is going to be 70. Okay, so what I'm going to do is I'm going to multiply this guy by 1, and I'm going to write 1 like that. And to get that to be a 70 in the bottom, I'm going to multiply top and bottom of this by 7. So I'll have 21x all over 70x squared. And 9 times 5 is 45 all over 70x squared. Now I can put them together. And I'll get 21x plus 45. Okay, which is correct. If I look at these, I'm going to notice that's the only one that's got 70x squared in the denominator. I can factor out a 3 from the top there. 21 is 7 times 3, so 21x is 3 times 7x. 45 is 3 times 15. I'm just doing that so I can see that it matches that one. All right, I want to subtract that. Let's see, what is that factored? It's x squared minus 4 squared. So it's going to be x minus 4 times x plus 4. Again, that's from Math 100. If I factor it, I might have a better idea what to multiply them by. So actually, let me... that factors as x plus 4 times x plus 1. Okay, so having done that, to get the common factor on the bottom there, I'll multiply this one top and bottom by x plus 1. And I'll multiply top and bottom of this one by x minus 4. Then they should have the same thing in the bottom. And I'll just write it as x minus 4 times x plus 4 times x plus 1, because the order doesn't matter. 3 times 2 is 2 times 3. The order doesn't matter. So putting these into one fraction, I'll have that. Now that's a correct answer, but I've got to clean up the top. Luckily, I don't have to multiply through the bottom, because just looking at those selections there, that I can leave it factored like that. This will be x squared plus x. Then I'm going to have minus 5x minus 5 times negative 4, which is plus 20. X minus 5x is minus 4x. That is my answer. X squared minus 4x plus 20. Simplify this. Well, remember, if you have a fraction divided by a fraction, that's the same thing as the fraction in the top times the flip of the fraction in the bottom. Because this is really just x over 9, the fraction in the top, divided by the fraction in the bottom. And in the rule for divide, it's times the flip of that. So in the bottom, 9 times 7 is 63. And in the top, I'm going to have x times all of that. So that'll be x squared plus 6x. Or they have it like this. Okay. Now, a whole means it is a value where it's undefined, but it cancels. So there is not a whole at x equals 4 in this. This is undefined at x equals 4. And we, in fact, get a vertical asymptote. The vertical line x equals 4 is our asymptote. This is undefined. This has a whole at x equals 4. So when it's in cancel form, we have that, but it has a whole at x equals 4. So where that point would have been on this function, we have to exclude it. And so the answer is this one. This is undefined at negative 4. So that has a whole at negative 4, but they said which one has a whole at 4, and it's going to be B. Find the x-intercepts. X-intercepts are found at real zeros of the numerator in canceled or simplified form or lowest form. Okay, so this will factor. It's x minus 2 times x plus 2. Now there's no cancellation, so it's already in lowest form. Real zeros of the numerator, what's going to make the numerator 0? If x is 6 and if x is negative 7. So I'll have an x-intercept at 6 and an x-intercept at negative 7. Finding vertical asymptotes. Vertical asymptotes are found at the real zeros of the denominator when it's in lowest form. So I can factor out an x here, and there's no cancellation, so it is in lowest form. What are the zeros of the denominator? Well, if x is negative 3, that'll make the whole thing 0, but also if x is 0. These are my zeros of the denominator. So I have two vertical asymptotes, x equals 0 and x equals negative 3. Finding vertical asymptotes, they're found at real zeros of the denominator in lowest form. Well, there's nothing to cancel here. It is in lowest form. My zeros, what will make the bottom 0 if x is 9 or if x is negative 4. So I have a vertical asymptote, x equals 9, a vertical asymptote, x equals negative 4. Find the horizontal asymptotes of the given function. Well, for horizontal asymptotes, we can see that the degree of the numerator is 2. And we can see that the degree of the denominator is also 2. And there are 3 cases. When the degree of the numerator and the denominator is the same, we do have a horizontal asymptote. Its equation is y equals the leading coefficient of the top, and the leading coefficient of the top is 8, divided by the leading coefficient of the bottom, which is 8, and the fraction 8 over 8 is 1. So the line, the horizontal line, y equals 1. So here's the horizontal line, y equals 1, is our horizontal asymptote. Find any vertical asymptotes. Vertical asymptotes are found at real zeros of the denominator in lowest form. And x squared plus 6 cannot be factored over the reals. What's the graph of that look like, of x squared plus 6? It's the graph of x squared shifted up 6 units. And so it has no zeros. It never touches the x-axis. And how will it factor? It factors as x minus 6i times x plus 6i. So it does have zeros, but they're not real zeros. They're complex zeros. So there are no vertical asymptotes. Find the horizontal asymptotes. Okay. The degree of the top is 2. The degree of the bottom is 1. And there will be no horizontal asymptotes. So we had 3 cases. If the degree of the top is smaller than the degree of the bottom, we have the x-axis. If the degree of the top and the bottom are the same, we have that case that we've already done. Now, if the degree of the top is bigger, so the degree of the numerator here is 2, and it's bigger than 1, which is the degree of the denominator. And we do not have any horizontal asymptote. Now, what about here? The degree of the numerator is 1. And the degree of the denominator is 2. So we will have a horizontal asymptote, and in that case, it's just the x-axis. If it's the x-axis, that is the line y equals 0. Find the horizontal asymptote of this. Again, degree of the top equals the degree of the bottom. So we do have a horizontal asymptote. It's the equation y equals the leading coefficient of the top polynomial divided by the leading coefficient of the bottom. And that gives me y equals 4. Is there a horizontal asymptote of this? Yes. The degree of the numerator is 2. The degree of the denominator is 2. They have the same degree. So again, it will be y equals leading coefficient of top divided by leading coefficient of the bottom. Oblique asymptote, if any. Okay. Well, there will not be one here. And we could have also graphed that to see. So 5 divided by, in parentheses, x minus 1. And zoom 6. Okay, I have horizontal asymptotes. Asymptote. Because the degree of the top is 0, the degree of the bottom is 1, and so we do have a horizontal asymptote, and it's the x-axis, which is y equals 0. But we do not have an oblique. Will we have an oblique? The degree of the top is 2, the degree of the bottom is 1. Yes, we have an oblique asymptote. So we know we're going to have one. And the way we do this is it's going to be, so degree of numerator is 2, the degree of the denominator is 1, so the top is 1 degree more than the denominator. Yes, there is an oblique or slant asymptote, and its equation is y equals the quotient that we get from synthetic division. So let's do this by synthetic division. I'm dividing by x minus the number in the box. And what goes here? I'm going to have 1, 8, and negative 2. And so 1 times 5 is 5, and 8 plus 5 is 13. I don't even need to finish this because my answer is going to be y equals the quotient. The quotient is that part where this line is. That is the constant, and that is x. So I'll have 1 times x plus 13. That is my answer. Give the equation of the oblique asymptote. The degree of the top is 2. The degree of the bottom is 1. Yes, we do. And it's going to be y equals the quotient from synthetic division. So I have this divided by x minus the number in the box. So this one needs to be rewritten. So the dividing by x minus the number in the box. And what goes here? The coefficient here is 1, then negative 4, then 8. So I get it started. 1 times negative 8 is negative 8. Then I add these two. Negative 4 plus negative 8 is negative 12. I don't need to finish it because this gives me the quotient. So where the line is, that's my constant term. That's my coefficient for x. And so my answer is the slant asymptote will be the line y equals the quotient. 1 times x minus 12. Okay, and so that concludes the midterm. So anything that you missed, make sure you go back and understand what happened.